Hi everyone, Mr. Lawrence again. The purpose of this video is to help us make a connection to kinetic energy. Even if we were at school right now, we would not be able to measure energy. There are no energy meters. So in a lot of our labs, what we'll do is try to collect some data and then see how different factors affect a variable. With kinetic energy, which is the energy of something moving, you might expect that that energy would depend upon how fast the object's moving, and you would be correct. It also depends upon the mass of the object. So we're going to collect some data this week, or work with some data this week, that has to do with objects at different speeds and with different masses. Now, even if we're at school, I don't think we'd need to collect some data because we have some information we know already. We've studied velocity quite a bit before. In order to get the energy, what we're going to use is the idea that we can calculate gravitational potential energy already based upon work we did the previous week. And using the example of an object falling, in this case, imagine a ball falling from a great height, and I've tried to illustrate that crudely on the screen here. We know that gravitational potential energy would steadily, as the ball fell, convert to kinetic energy until it was about to hit the ground, when all of the energy would become kinetic energy. The idea of this total conversion falls under what we call the conservation of energy. All the gravitational potential energy eventually turns into kinetic energy. So in order to do that, we're going to again use Google Sheets, and I hope you watch the other video to see how to enter formulas. Let me flip to this sheet, which is what you guys will be opening up. Just to start off this week, we're going to ignore the energy part of it and just review some of the concepts of free fall and object falling. So I've chosen a column, or I've set up a column of times here between 0 and 6 seconds. We're going to calculate displacement as the object falls, something you've done before. And then we're going to measure the height and the velocity of the object. Velocity is also something you've calculated before. In order to do this, you'll want to review perhaps some of the equations we developed so far this year. These are all your mathematical models, and if you were to look at your equation sheet that I helped you develop in our class, many of these will be on there. You'll also notice perhaps that I've added in Hooke's law, which we developed recently. I put that in with forces because really it is a force equation. And then I made a column for energy equations here, elastic and gravitational potential energy. Ideally, at the end of this lab, we'll add another row here for kinetic energy. But where you'll want to concentrate is in this column for acceleration. Remember, objects that are freely falling have an acceleration of 9.8 meters per second squared, which is down here in this list of all the variables here. As the object falls, going back to this sheet, you can calculate the displacement delta x using one of the equations that I just showed you. For each time here, you're going to get a new displacement, and you should be able to calculate that using a formula that you'll enter. Remember, start with an equal sign, and then type in the formula you want to have Sheets calculate for you. And when you finish, you'll be able to drag that down. Once you have your displacements, the heights are pretty simple to get actually. The ball starts at a height of 180 meters. After 1 second, it's going to fall a certain distance, this displacement that you'll calculate. Let's say, for instance, that displacement was 10 meters. The new height then would not be 180 meters, but the new height would be 180 minus 10 meters. Or in other words, 170 meters. I've set this up choosing numbers carefully, so if you do things correctly, when you get to the bottom here, after 6 seconds, your height should be 0. Finally, the velocity. As the ball falls, it will get faster. Remember what the acceleration from gravity is, and this should be a pretty simple formula for you to enter. Or if you prefer, you could just do the math in your head and fill in each value. Up to you. I hope you have this done by Wednesday this week. And we'll proceed with the next part of this, which is to more carefully analyze how velocity and mass affect the kinetic energy for the object. Hope you're all well. Take care.